Well, hello, wonderful third grade math teachers. We're so excited that you're joining us for our prep talk video to help get you prepared for your PLC the week of September 19th through 23rd so that you are ready to teach the content for September 26th through the 30th. Remember that this video is meant to give you some of the pre-planning tools so that you can walk into your PLC and be a contributing member to that team. So we're going to look at some of the released items, talk about some of the strategies that we would use with students to solve these problems, and hopefully it leads to a great discussion in your PLC about how to create a great lesson for students to learn the content. So as we look at an overview of the week, you'll see that we begin teaching on Wednesday subtracting 3-digit numbers on a number line and applying that to partial differences. This is an extension of what you did the previous Friday when you had students subtracting on a number line with 2-digit numbers. Then on Thursday and Friday, we will go into 2 other strategies that you can teach students to help them understand the concept of subtraction. We want to do this in order that when we get to the standard algorithm, that algorithm begins to make sense because students have seen a conceptual way to understand that standard algorithm. You'll notice that the TEK for the week is 3.4a. We will be covering that TEK all 3 of these days. And this TEK does not just say to subtract, but it actually says to solve with fluency, 1-step and 2-step problems that involve addition and subtraction. That will be our focus this week, is the subtraction, but we're going to do this in the context of problem solving. And so this won't just be what is 368 minus 215. It will be something in the context of a real-world problem where students are having to decipher how they will attack solving the problem. So we will have to teach students how to think as problem solvers and how to be mathematical thinkers so that they are able to solve these word problems. So as we look at this first released item, we see that there are 297 peach trees on a farm. There are 615 peach trees on a different farm, and the question is asking what is the difference between the numbers of peach trees on these farms. Now, the first thing I want to mention is that this is a real-world problem, and so we're going to have to teach students how to know which operation to use in this case. We want to try to avoid using keywords to direct our path. That is different from academic vocabulary. Please absolutely teach academic vocabulary in your classroom. And you can find academic vocabulary on the field guide so that you know which words to teach students and what they mean. You can also sometimes pick up on some of the academic vocabulary in the questions themselves. For example, this word difference shows up in several of the released items, and that is an academic vocabulary term. What we mean by key words is teaching a student, when you see this word, it means do this. We want to try to avoid that because we would rather have students close their eyes, immerse themselves into the problem, and then try to decide what is the problem asking me to accomplish. You'll find much better results if you have your students really think through the problem first. Maybe do a turn and talk with your students so that they can talk amongst themselves and try to figure out what operation the problem is having us do. In this particular case, we're going to be doing 615 minus 297. And on Wednesday, the strategy we will be teaching students to solve this is counting up on an open number line. And so we would want students to start on the left with the smaller number, which in this case would be 297, and then be able to count up to 615. There are going to be many different ways for a student to do this, but it can be your job as the teacher to help show them a couple of clever ways in order to count up to 615. And so one way that we might do this is to start by counting up to 300. Well, I know that that's just going to be an addition of 3. Then from 300 to 615, maybe we could go all the way to 600. And so if we go from 300 to 600, that's a pretty obvious count up by 300. Then from 600 to 615, some students may be able to go straight from 600 to 615 and add 15, but other students may need to go first of all to 610, which would be a jump obviously of 10, and then finally take that final jump to 5. And then what we would have them do is add all of their jumps. And so 3, 300, 10, and 5, if we were to add all of those together, then what we would end up getting is 318, which is the final answer to this problem. One thing that Sherry Height mentioned, and I think it's a great observation about these released items, is that a lot of times you'll see the smaller number actually given before the larger number in these real-world problems. So you'll want to have a conversation about that with your students and practice problems where they actually have to make sure that they put the larger number first in the subtraction sentence. But when we do this on a number line, then we want the smaller number on the left and the bigger number on the right. In this next problem, Erica's goal is to practice playing her guitar for 300 minutes this week. On Sunday, she practiced 117 minutes, and on Tuesday, she practiced for 58 minutes, and we need to know how many more minutes does Erica need to practice in order to meet her goal. This is an instance where if you just teach a student about key words and say, well, how many more means subtract? Well, this is actually a two-step problem, so there's actually going to be some addition involved in this problem before we get to the subtraction. And so that's why it is not a good idea for you just to worry about key words when solving real-world problems. What we see here is that we're going to have to add the times that she practiced on Sunday and Tuesday and then subtract that from her goal of practicing 300 minutes this week. So we would start by adding those two times for Sunday and Tuesday. You can do this using the standard algorithm if you want to, since you've taught that to your students already. And so if we add here, this would be 5, we would carry the 1, that would give us 7, and then 1. So 175 is the number of minutes that she practiced on Sunday and Tuesday. Then we're going to figure out the difference between 300, which was her goal, and 175, which she's already done. And so 300 subtract 175 is what we're trying to solve in this particular problem. Now on Wednesday, we're going to teach students to do this on an open number line by counting up. So again, just like in the previous problem, we would have 175 and 300, and we would figure out how to count up to 300. Maybe the first way would be to go up to 180, so that would be a jump of 5. Then maybe you could jump up to 200, and so that would be a jump of 20. And then finally, you could go another 100, and then add up those 3 jumps in order to get the difference in this particular problem. And so 100 plus 20 plus 5 would of course be 125, which would give us an answer of A. Now on Thursday, we were going to teach a different method, which is basically where we have students subtracting across zeros and finding a constant difference in the two numbers that we are subtracting. And so let me demonstrate what we mean by that. We're going to begin by writing the subtraction vertically like this, and then notice that if we try to subtract this using the standard algorithm, we can't subtract 0 minus 5. And so what we're going to do instead is we're going to subtract 1 from that 300, which means I also have to subtract 1 from that 175 to keep that constant difference between the two numbers. Sometimes showing students this on a number line can be really helpful because they'll be able to visualize that the differences are actually the same if we subtract 1 from both numbers. Then what we end up getting is 299 minus 175, and that makes the subtraction much easier. Now I can do 9 minus 5, which is 4, 9 minus 7, which is 2, and 2 minus 1, which is 1. And obviously I've messed up here, so I'm going to back up just a little bit. And this is the nice thing about doing things multiple ways, is I forgot to subtract 1 from my 175. And so if I can find my eraser here, I'm going to erase that 175 and put a 174, and that way I can fix my 4 here and make it 9 minus 4, which is 5. So sorry about that. We've got that fixed now, but that again is a good way to demonstrate that it's always a good idea to maybe work these multiple ways so that you can confirm your answer. And so this subtracting across zeros and making a constant difference between the two numbers can be helpful whenever students are having to subtract across zeros like they are in this particular number. In this problem, a movie theater has 710 seats, 158 are red, 247 are black, and 119 are yellow, and the rest of the 710 seats are green, and we want to know how many of the seats are green. And so again, this is a two-step problem where students will have to add the number of red, black, and yellow seats first, and then subtract that from the total number of seats in the movie theater in order to figure out how many are green. And so you want to make sure that in your lesson you are working real-world problems like this so that students are having to close their eyes, put themselves into the story of the problem, and determine what they will have to do in order to answer the question. And so in this case, we're going to have to add the three numbers here of the different colored seats. And so just adding this using the standard algorithm, 8 and 7 will be 15 plus 9 will be 24, and I'll carry the 2. 5, 4, and 1 will give me 10 plus the 2 is 12, which means I'm going to carry one more 1, and that's going to end up with 524. One real quick note is that as you begin these lessons, it might be a good idea to do a warm-up or perhaps a number talk over addition, because as we can see in these 3.4a questions, when it's two-step, a lot of the times those steps are addition and then subtraction. And so it might be a good idea to revisit those addition skills using the standard algorithm or maybe some of the other techniques that you taught students earlier in the year so that they're well prepared to solve these particular problems. Now, we know that the next thing that we're going to have to do is subtract from 710 so that we can get the number of green seats. And so we have 710 minus 524. And so if we were going to do this on Wednesday, our strategy would be to solve on an open number line. And so we would start with 524. Our objective is to count up to 710. One of the first jumps we might make would be to, let's say, 530, just getting to a nice number there, and so that would be a jump of 6. Then maybe we could jump up 70 to go to 600, and so that would be a jump of 70. Then we could maybe go to 700, and that would be a jump of 100, and then finally to get to 710, that would be adding 10. And so if we add up 100, 70, 10, and 6, that total is going to be 186, which would be letter A. Now on Thursday, we're going to teach the strategy of subtracting using constant differences. And so 710 minus 524. And so I immediately see that 0 minus 4 can't be done. And so one thing that we can try is subtracting the same number from both of these numbers so that I'm not subtracting across zeros. Well, if I try my same strategy from the previous problem where I subtract 1, and hopefully I'll do it correctly this time, there we go, what I notice is that I'm still going to be subtracting across a 0 because I still have a 0 here in the tens place. And so that's not good. This really didn't help me that much. And so what we can try then is to keep subtracting until we don't have a 0 in one of those places. And so what I notice is that if I subtract 10 more, that's going to get me away from having that 0 in the tens place. And 709 minus 10 would be 699. And then 523 minus 10 would be 513. Now when I do the subtraction, it's going to be very straightforward. 9 minus 3 in the ones place is 6, 9 minus 1 in the tens place is an 8, and 6 minus 5 in the hundreds place will be 186. and so we get the same answer in that particular case. One thing I would suggest to you, once you get to Friday or maybe the following Monday, when you sort of wrap up this lesson, is talk about the advantages of the different methods for each problem. It might not have made a lot of sense to use constant differences, which is the Thursday strategy, on this particular problem. Whereas on the previous problem where we were subtracting from 300, it made a lot of sense to just subtract 1 from 300, get 299, and that made the subtraction really straightforward. So that could be a really powerful discussion of the advantages of the different methods so that students are able to use the one that best fits the problem they are trying to solve. We wrap up the week on Friday by talking about subtraction using base 10 blocks. Sherry went over this strategy with you in last week's video when we talked about doing this with 2-digit numbers, and now we are extending it to 3-digit numbers. This is the same star released question that we worked earlier in this video, and so we already know that the answer is 318. Let's demonstrate how we would get to this result using base 10 blocks. You'll notice that I have 6 hundreds, I have 1 10, and I have 5 ones. That corresponds to the bigger number that I am trying to subtract from in the subtraction sentence, 615 minus 297. You'll notice that the standard algorithm sort of it works here, but it doesn't work intuitively because I can't subtract 5 from 7. And so when we get to the standard algorithm and we teach that to students, we want them to understand what borrowing or regrouping actually looks like. And so that's why we present them this strategy. If students were going to use this strategy on the STAR test, they would have to create these models themselves. And so that's something that you can certainly teach students to do, but it's going to be a lot of work. And so really the idea behind teaching this strategy is so that students can visualize and conceptualize what is going on in the standard algorithm. Now, what we're going to begin doing is starting to subtract 5 from 7 in the ones place. Well, you'll notice that I can't take 7 away because I don't have 7. And so this is where the borrowing or regrouping idea comes in. I'm going to take my 100 here and change that into 10 ones because that's equivalent, right? I can change that 110 and make it 10 ones and put that in my ones column. And so now I have 15 ones to subtract from. And so we are going to subtract the 7 ones from those 15. And so there is 5 of them right there, and then 2 more will take away 7. Well, how many are left over in the ones place? I see that 8 are left over in the ones place. Then what we're going to do next is move on to the tens place. We know that we no longer have that 1 there. Now we have 0, and we're trying to subtract 9 from 0. Well, we certainly can't take away 9 if we don't have any, and so what we're going to have to do is borrow or regroup one of our hundreds and make them into tens. And so we know that 1 100 is the same as 10 tens. And so 10 tens is what I'm going to put now here. And I apologize for my terrible drawings, but just bear with me here. Here are my 10 tens that I used when I borrowed from the hundreds place. And so now I know that this is a 5, which is going to make this 10 in the tens place. What we're doing is taking away 9 from that 10, and so coming in here and just taking away 9 of these tens is going to leave us with 1 in the tens place. Then finally what we're doing is we're taking away 2 hundreds from the 5 that we have left over. Notice that we had 5 left over here. We're going to be taking away 2 of those so that we get how many is left over in the hundreds place, and we see that there are 3 hundreds left. And so putting that all together, we see that we get the same result as when we counted up on a number line of 318. And again, this is probably not the method that you would want students to use on the STAR test. If it makes the most sense to them, then certainly. But really, the idea behind this day and teaching this strategy is so that when we go to the standard algorithm, the borrowing and regrouping process makes sense. And you can point them back to, hey, remember when we did this using base 10 blocks? That's what's happening when we cross out that 5 and make the tens place a 10 instead of a 0. And so we want you to be able to go back to this memory that you've created of using base 10 blocks so that students are able to conceptualize and visualize this strategy. We hope this video was helpful to you in learning some of the different strategies that we teach students in how to subtract. Make sure that you're working those real world problems so that students are having to work through which operations they're going to use, when it is a one-step, when it is a two-step problem. We want to make sure that we're doing subtraction in the context of problem solving. If you have any questions, we're going to be having office hours again on Tuesday, September 20th from 3:30 to 4. So you can jump on, ask any questions that you might have. We would be happy to help you plan your lessons, understand what's going on in your PLCs so that you can turn around and deliver great instruction to your students. One way that you can extend these lessons, if you have students that are just absolutely crushing it in problem solving using subtraction, is you could have students create their own word problems in order to solve, and even have them come up with a key that has the correct answer, and maybe even an exemplar that shows how to solve the word problem that they wrote in each of the 3 different strategies that you taught this week. And just as you did last week, if you joined us for that video, please fill out this survey using either the link provided or the QR code that you see on the left. This will let us know that you watched the video and help us serve you better in future videos. We wish you the best of luck in your PLCs planning out your lessons. Please feel free to reach out to either me, Ryan Castle, or Sherry Height, our 3rd through 5th grade math facilitator, if you have any questions about the curriculum resources or how to best teach this concept to your students. Thank you guys so much, and have a great rest of your day.